So as I was mentioning, if I draw this clearly, because there was some other values here as well. So let's say this is 0, this is 2, this is 4, then we have, let's say, 6 over here. And we won't need actually more than that because all the values are within this range. For 0, we have a doublet here. And in between these 2 and some other region, like we have this multiple values. Okay, so that means it's a multiplate. Okay, that means it's a multiplate. And more than 2, we have a singlet here. We have a singlet here. And within this, like, near to 4, we have a doublet here. So these are clear, isn't it? We can clearly observe them. And we can know that there is a multiplet over here. Now, our number of carbon atoms you can find using this value. Our number of C equals to number of C is equals to our, 100. Sorry, was that 100 or 1? Let me check it out. Previously, I didn't check it out. I'm really sorry. So 1 divided by 1.1 into 0.9 divided by 20.4. Yeah, that was actually 100. So 100 divided by 1.1 into 0.9 divided by 20.4. So yes, that's actually 100. So in my case, like here, the solution is given as 1.1. So 100 over 1.1 into 0.9 divided by 20.4. Since this is m plus 1 over m, so reciprocating this, we should get something near to 4. Okay, that means we know our molecule should have what? 4 number of carbon atoms. So 4 carbon atoms should be here. Also, okay, C atom equals to 4. Now, from here, we can get to know that there are what? 4 possible environments. Now, let's see from like over here, we can observe this is for one carbon's position and its environment has 2 peaks. That means 1 hydrogen. That means its corresponding or adjacent carbon should have 1 hydrogen. Now let's see for the multiplate, it's a bit trickier in this case, but let's leave it here because this is trickier to understand. So let's go for this portion, which is more than 2. This is a singlet. That means it should be a special functional group. Now, if we, let's say, observe this data booklet. Sorry for the mess. Let's clear things up. So over here, if you try to see what special group could be here, could it be a nitrogen, like ammonia? Could it be? Let's see. This is not an amine. Sorry, this could be an amine, but we're not sure if it could be an amine or not. But let's mark it because it is in between that range. There is more than 2, so it could be amine, but still it might not be amine. But let's mark it. Fine, we've marked it. And then it could be an alcohol. Yeah, because it is in between 0.5 and 6.0. Obviously, it's a big range here given, but still, 2 is in between 2.2 or 2 is in between this range, isn't it? So these are possible like candidates. And do we have anything else? Anything else? Anything else? This. Okay, remember, don't get confused over here. Okay, you might think, okay, this could be a possibility. But this is not a possibility because it says what? Aromatic ring. Aromatic ring is which one? Benzene ring. So AR means here is the benzene. If there was a benzene, that means it should have more than 4 carbon because benzene ring itself has 6 carbon atoms. That means it should be 10 carbon atoms in that case. Okay. Okay, then that means this is not going to be the case. Anything else? We are getting some vibe from this portion, but still we're not sure. But we know that this portion is actually like, so far, let's consider this is the alcohol or this alkyl, but we're not sure still because carboxylic acid cannot be here. Okay, over here, this cannot be a carboxylic acid. This could be an aldehyde, but carboxylic acid cannot be in this case. Why? Because carboxylic acid is more than 9 and less than 13. That means if this is the position, like if this has to be the part, then remember this cannot be a carboxylic acid COO group. Rather, it has to be an aldehyde. Ketone does not have like CH3 COO, and in the other portion, there has to be a hydrogen, like ketone cannot be in this case, because let's see if this could be ketone or aldehyde. This might also be an aldehyde as well, but so far it is makes much more sense with that structure. We have carbon C double bond O group, and we have COH group, okay, alcohol group. If that's the case, we have two more like peaks here. Okay, this is for, let's say, some other carbon atoms. Okay, let's say for some other carbon atom. I'm not sure which carbon atom, but this carbon atom has again like a corresponding hydrogen, like a corresponding carbon who has one hydrogen atom, and one hydrogen atom we already have one. So this could be a possibility that this is the molecule and we have one carbon over here. So its relative is, or its neighbor is this one. So this could be a possibility because we have so far got two doublets. That means this could be a possibility that this carbon's environment is this carbon and that carbon's environment is this carbon. That could be a possibility. Now, there is an alcohol group. Now, with which part is this alcohol bonded? Okay. Before finding that, we have to see actually how many hydrogen atoms are there. Now, is it possible to find how many hydrogen atoms are there? Might be, but with these multiple plates, it's not clear here how many hydrogen atoms are there because we don't know how many peaks are here. From this, like, so for distinguishable peaks, that's possible, but from this multiplate, it's not possible. There comes this molecular ion peaks value. Okay, in such situation, they will give such values. Now, how can we find this? We can find it in this way, that we have how many carbon atoms? 4. That means 4 carbon atom has a mass of what? 12. Like each carbon atom has an AR, atomic mass of 12. That means 4 carbon, 4 into 12. Okay, fine. Now, is there anything else we got so far? We got, or we can think, we know actually there is like an alcohol group. Ketone in this case, or aldehyde in this case, let's say it is not possible. Okay, let's eliminate this. Let's eliminate this for this moment because we have to be sure with what we are dealing with.